Hello everyone. Today I'll be presenting on developing and debugging Android components. Android components form the core foundation of any Android application. So understanding how to build, connect and debug them effectively is essential to create stable, efficient and user-friendly apps. So let's go on. Now I'm going to discuss about developing and debugging Android components. So now agenda, a deep dive into Android's foundation. So here's the agenda for today's session. Like we will begin by understanding the main Android components, then look at their life cycles and how they interact. Now, next, we will discuss common debugging strategies, followed by tools and techniques like Logcat, ADB, and Profiler. So we'll go through a short practical example, and finally, I will share some best practices to make sure your app's production easy. And the next, Android components, the four pillars of an app. So every Android app is built around four major components: activity, service, broadcast receiver, and content provider. Activity, it represents a single user interface screen. And service, it runs background tasks like downloading data or playing music. Broadcast receiver, it listens for system or app-wide broadcasts such as incoming messages or boot events. Content provider, like it manages and shares app data securely across apps, and each of these components must be declared inside the Android manifest.xml. Otherwise, the system won't recognize them. And here's the manifest code snippet and mention how each tag like activity, service, etc. registers a component. And understanding component lifecycle and pitfalls. So every component has a life cycle and managing it properly help prevent memory leaks and crashes. Like activities. It goes through states like on create method, on resume method, on pause method, and on destroy method. So you should save data in on pause method or on stop method. Services. Like services have an on create method, on start command method, and on destroy method. So they must be stopped properly. Broadcast receiver uses only on receive method and should complete quickly because they should run on the main thread. And the content provider, I like it handles methods like query method, insert method, and must be thread safe. So common issues include context leaks, unregistered receivers, and threading errors. Now, illustrative code interacting components. So here's an example of how components interact. In main activity, we use an intent to start a background service. So my service performs the background task while a broadcast receiver can listen to system events and trigger actions. So this shows the communication flow between different Android app communicate components. And this is the starting a service main activity.java snippet code, and this is my service.java background. And next, debugging fundamentals like logging with logcap. So when debugging, the first and the most powerful tool is logcap. So it shows real-time logs from your app and the system. So there are the five main log levels like verbose, debug, info, warn, error. So verbose, like it is the all logs usually for development only, and debug for debugging app flow, info for general information messages, and warn like potential problems, and error actual issues that cause failures. So always use clear tags like private static final string tag that equals my service, easily filter logs. And remember to remove verbose logs from release bills. And here are the some advanced debugging with breakpoints. So next we have the debugging in Android Studio. So breaking points let you pass execution at any line of code. So you can step through your code line by line, check variables, values, and even attach the debugger to a running app. So this helps find logical errors that simple logging can't really reveal. And now external tools like ADB and Profile. Now, here beyond the IDE, there are powerful external tools like ADB, like Android Debug Bridge. Like it lets you control your device from the command line. Like it gives examples like ADB Logcat, like it view logs, and ADB Shell and broadcast, like test receivers. ADB Shell dumps sys activity, like it inspects running components. And next one is Android Profiler, like it tracks CPU, memory, and network usage to detect bottlenecks. Strict mode, it helps identify accidental main thread operation or leak early. It's great for catching bad practices during development. Now here is a case study like why is my service is not starting. So here a real debugging example, like if your service doesn't start, verify the intent and sell to start service method. Check if it is declared correctly in the manifest. Add breakpoint inside on create method of the service. Use ADB shell, the dump sys activity services to see if it is running. Review logcat for errors like security exception or class not found exception. On Android 8.0 version and above, use start foreground service method for background work. So this approach helps narrow down the exact cost. And the last one is best practices for robust Android development. So to build reliable and maintainable Android app, here are the 5 steps like logging discipline, test on real devices, secure components, integrate crash reporting, lifecycle awareness. So logging discipline means like it uses consistent tags and remove debug logs in production and test on real devices like illuminators can't relate every hardware behavior and secure components like it uses permissions to protect exported activities or services like integrate crash reporting like it has tools like Firebase Crashlytics helps crash catch runtime errors in real apps and lifecycle awareness like it always release resources and unregistered receivers to prevent memory leaks and ANRs. So following these ensures your app is secure, efficient and professional. So by concluding this session, to conclude, developing Android apps means understanding how components like activities, services, broadcast receivers, and content providers work together. So, debugging efficiently, use logcat, breakpoints, and profiling tools helps ensure your app runs smoothly. So by applying these best practices, we can create apps that are both powerful and reliable. So in this project, I created 2 buttons, start service and stop service, which helps to start and stop a background service manually. Additionally, the app also uses a broadcast receiver that automatically starts the service after the phone reboots. So let's explore each part of the project step by step. So here we can see the layout file activity underscore main.xml. I have designed a very simple user interface with 2 buttons, one labeled start service and another is stop service. So these buttons are connected to the functions in the main activity that control the background service. This minimal UI is enough because the focus of this project is on background processing rather than the UI design. And the next one is main activity dot Kotlin. So let's look at this main activity dot Kotlin. This file handles the logic when the user clicks either button. So button initialization, creating an intent, start button, click listener and stop button, click listener. Here button initialization. The find view by ID function connects the buttons from XML using their IDs, button start and button stop. Content creating an intent. So here I created an intent named service intent for the my service class. This intent acts as a communication medium to start or stop the service. Start button click listener. So inside start button dot set on click listener, we call start service of service intent to start the service. A toast message service started appears as feedback to the user and the stop button click listener. Similarly, inside stop button dot set on click listener, we call stop service of service intent and show a toast service stop. So main activity access the control center that directly interacts with our background service. And the next one is Android manifest.xml. So in the manifest file, we register all major components of our app. So the main activity is declared with an intent filter containing main and launcher, which makes it the entry point of the app. The My Service is also registered here using the service tag, allowing the system to recognize it as a background service. Finally, the My Receiver is declared as receiver with an intent filter for the action boot completed. And this means that once the device finishes booting, the broadcast receiver will get triggered and start the service automatically. The manifest file is crucial because Android requires all components to be declared here before execution. And the next one is myservice.kotlin file. So this is myservice.kotlin file. This file defines our actual background service. So the myservice class extends the service class from Android. Inside it, I have used a tag variable for logging purposes. So we can track service activity in logcat. So now it contains three main lifecycle methods. OnCreate method, OnStart command method, OnDestroy method. So onCreate method, it called when the service is first created, like it logs service created. And onStart command method, like it called every time the service is started using start method, it logs service started and returns start sticky, meaning the system will try to restart it automatically when it is killed. On destroy method, it is called when the service is stopped. It logs service destroyed for debugging. So this ensures that the service can run tasks the background independent of the user interface. And the next one, the last one is my receiver Kotlin file. So this is the my service my receiver.kotlin file. Here we have the broadcast receiver my receiver.kotlin. So the class extends broadcast receiver, which allows the app to listen for system level broadcast, and the on receive method executes whenever the specified event occurs. In this case, it listens for action underscore boot underscore completed. So inside it, we have log the broadcast reception for debugging. Check if the received action is indeed boot underscore completed. If yes, create an intent for my service and start the service again. So this ensures that even if the phone restarts, our background service will automatically start again. And the output demonstration, the last final one. So finally, we can see the output on the eliminator screen. So when we click the start service, so when we click on the start service, we get a toast message service started. So it displayed. So this confirms that the service is running in the background. So when I click stop service, toast message appears like service stopped appears. So indicating the service has been stopped. So if I restart the eliminator, the service automatically restarts due to the broadcast receiver we implemented. So, hence, our app successfully demonstrates how Android services work in combination with broadcast receivers. So, by concluding this session, like to conclude this project clearly explains the concept of background services in Android and how broadcast receivers help automatic tasks like restarting the service after device boot. So these are important components in Android development, especially for tasks such as music playback, notifications, background data sync, or sensor monitoring. Thank you.